Let us take up two illustrations to understand the Rainman problem. Here we have a type 1 question, which wherein a simple trigonometry is applied. We consider only one triangle and we apply. We'll take up another question where we'll be seeing the complication that will arise in the rain umbrella problem and where we have to use two triangles or three triangles. So here the question states that a man is traveling at 10.8 kilometers per hour in a topless car on a rainy day. Let us first convert the velocity of the man to meters per second, because you can see in the options the speeds are in meters per second. So velocity of the man is how much? It is given as magnitude is given as 10.8 kilometers per hour. How do you convert kilometers per hour to meters per second? We need to multiply by 5 by 18, isn't it? Now 10.8 can be written as 108 divided by 10 into 5 by 18. So 18 and 6 goes 18 goes 6 times in 108. 18 6 are 108, and 5 ones are 5 twos are 10, and 6 by 2 is nothing but 3. So velocity of the man is 3 meters per second. And the question tells that he holds the umbrella at an angle 37 degree with the vertical so that he does not wet. If the raindrops are falling vertically downwards, what is the rain velocity? So rain velocity is asked. So we need to find the speed of the rain. The question clearly tells that the raindrops are falling vertically, isn't it? Raindrops are falling vertically and the man is moving in the forward direction. So we need to find the direction of the umbrella. The direction of the umbrella, as I discussed in the concept videos, the direction of the umbrella will be in that direction in which the man is experiencing the raindrops, isn't it? And how will we find that? That is nothing but simply VRM vector, velocity of the rain as seen by the man. So velocity of the rain as seen by the man can be written as VR vector minus VM vector, which can be written as a VR vector plus negative of VM vector. So what we do, we take negative of VM. This is VR, and negative of VM will be in this direction. And what we have to do with these two, we have to add them. You can add using triangle or parallelogram law. So these are the two sides, two vectors represented by two sides of a triangle. The resultant is given by the third side of the triangle taken in the opposite order. This is nothing but now my VR vector plus minus VM vector, and that is the direction of the raindrops as experienced by the man. That means the man will see that the raindrops are falling in this direction. So he will basically hold the umbrella in that direction, isn't it? And the question tells that he holds the umbrella at an angle 37 degree with the vertical. So this is the umbrella and that is making an angle how much? 37 degree with the vertical. And the speed of the man, what is the magnitude of the speed of the man? That is nothing but 3 meters per second. I need to find the speed of the raindrops. So we can apply the tan function. So tan 37 degree is nothing but opposite by adjacent. Opposite is 3. Adjacent is VR. Tan 37 is nothing but 3 by 4. So 3 by 4 is equal to 3 by VR. So 3 will cancel. So the magnitude of the raindrop speed is nothing but 4 meters per second. So that matches with option number 4. Let us take up a next problem to understand the complications that can arise in the Rainman problem. And these questions are usually asked in the JEE exam. Let us see the question. When man is standing, the raindrops appear to him falling at 60 degree from the horizontal from his front side. So you need to understand each and every part of the question. Every part of the question is important. So here in the first case, the man is standing. I'll write here first case, man is at rest. Man is standing. So basically man is at rest. He's just standing, isn't it? And he feels that, correct? Raindrops appears to him. Raindrops appears to him. That means the velocity of the raindrops as experienced by the man is given to falling at him at 60 degree from the horizontal from his front side. So if this is the man, okay, if this is the man, he's just standing, the raindrops are falling at him at an angle, how much? At an angle 60 degree from the horizontal position, making an angle 60 degree. So obviously he'll hold the umbrella in that direction. Now from the first part of the data, what you can find, what is VRM actually? VRM is nothing but VR vector minus VM vector, isn't it? But man is at rest in the first case. That means the speed of the man is 0. That means whatever is the direction of the rain, correct, with respect to man, that is nothing but the actual speed of the raindrops. I hope you understood. So in the first case, the man is at rest. So VR vector direction, the velocity of the actual raindrops is equal to the velocity of the raindrops as experienced by the man. That means we got to know that I will highlight in some other color, that is the raindrops are actually falling at an angle 60 degree with the horizontal, because VRM and VR vector is same in the first case. So keep this point in mind. Now, the second case is when he is traveling at 5 kilometer per hour on a horizontal road. Now, in case to what happens, he is traveling at 5 kilometers per hour. And the options are the actual speed of the rain kilometers per hour. So we will not convert into meters per second. In case two, in situation two, when he's traveling, so the man is moving in the forward direction. Man is moving in the forward direction with a speed of 5 kilometers per hour on a horizontal road. They appear to him falling at 30 degree. They appear to him falling at 30 degree from the horizontal from his front side. So in the second case, the velocity of the raindrops as seen by man appear to him means velocity of the rain as seen by man is making how much angle? It is making an angle 30 degree, isn't it? With the horizontal, you need to calculate the actual speed of the rain, correct? Actual speed of the rain. How do you calculate? Now, from the second case, again, I'll write VRM. So in the second case, VRM is going to be VR vector minus VM vector. Now, negative of VM, we can simply write it as VR vector plus negative of VM vector. Again, I'll make use of the triangle law, where the triangle law states that represent the two vectors which you want to add by adjacent sides of a triangle, then the resultant will be given by the third side taken in the opposite order. First, I want negative of VM. So let me construct negative of VM. So carefully see here, plus VM I had. So negative VM will be in this direction, isn't it? And then VR vector. What is VR vector? VR vector we already saw in the first case, as seen by the first case. VR vector is making an angle 60 degree with the horizontal. So basically VR vector is like this. This is my VR, which is making an angle how much? Which is making an angle 60 degree with the horizontal, isn't it? 60 degree with the horizontal. So I have represented VR and negative of VM by adjacent sides of a triangle. So how do you add them? The resultant of the two is given by the third side of the triangle. That is given by the third side of the triangle taken in the opposite order. So this is my VRM. So constructing is very, very important. As you can see, we are using now one more triangle. It's not a right angled triangle now, isn't it? So it is some other triangle. And in the second case, how much is VRM making? This is nothing but 30 degree. This is nothing but 30 degree. So if this is 30 degree, obviously there's also 30 degree alternate angle. And if this is 60 degree, extend this. This is also going to be 60 degree. Now, I will not use any trigonometry because it's not a right angle triangle, but I can easily find all the measurement of all the sides using sine rule. Using what? Using sine rule. You know sine rule, basic sine rule, you know. That is the three sides and three angles of a triangle are connected by some rule called sine rule, which we have studied in concept videos. I'll just write it once again here. So if this is angle A, the side opposite to angle A is side A, and this is angle B, the side opposite to angle B is side B, denoted by small b, and this is angle C, and the side opposite to angle C is small c, side C, and these three angles and three sides are connected by a rule called sine rule, which is A by sine A equal to B by sine B equal to C by sine C. A very important result. Parallelogram law is cosine rule, and this is the sine rule, which we can use to find the sides or the directions. So it's very important sine rule, which we can easily use to calculate the measurement of the vectors here, the magnitude of the vectors. So first, let me draw the vector properly here. The three sides. This is VR, okay, and this is nothing but VRM, and this is 30 degree. This whole angle is 60 and this is 30 degree. So obviously this is also going to be 30 degree. This is also going to be 30 degree. And this is nothing but minus of VM vector. And this is nothing but 60 degree. So first what you do, you take one side. You take one side, which is nothing, which is that side. Let me take VM. So VM, magnitude is just VM divided by sine of the angle between the other two vectors. See, when you're writing side A, what is this angle A? Angle A is nothing but the angle between the other two sides, B and C. Next, when you're writing side B here, when you're writing side B here, what you will be doing? B divided by sine of the angle between the other two sides, isn't it? Side B divided by angle B is nothing but the angle between the other two sides A and C. And C divided by, this is the side C divided by sine of the angle between the other two sides A and B. So same thing we need to apply here. You fix one side, this is Vm, divided by sine of the angle between the other two vectors. What is the angle between the other two vectors? Which are the other two vectors? One vector is Vrm, one vector is minus Vm, and one vector is Vr. So what is the angle between the other two vectors Vrm and Vr? 30 degrees. So sine 30 degree. You can use some trigonometry by dropping a perpendicular here also. You can do that, but I'm not interested in doing that. I want to show you using sine rule method. You can do some simple trigonometry and you can find out. The physics is only till here. The remaining thing is pure mathematics. I'm using sine rule. And let me take the other side now. Which is the other side? Vr. So Vr divided by, what is the sine of the angle between the other two sides? Which are the other two sides excluding Vr? Vrm and minus Vm. So what is the angle between the two? That is also 30 degree, sine 30 degree. And that is equal to what, which is the last side remaining? Vrm. Vrm divided by sine of the angle between the other two vectors. Sine of the angle between the other two vectors. The other two vectors are, carefully if you see, Vr and negative of Vm. As we have already studied, the angle between the Vr and minus Vm, the angle between two vectors is nothing but the angle formed at the intersection point of two heads or two tails, isn't it? Here head and tail is coinciding. So this is not the angle between the two vectors, isn't it? This is not the angle. You just extend minus Vm. So minus Vm, if you extend, this is the angle between the two vectors because their heads are coinciding. That is nothing but 60 degrees. So sine 60 degree. Yes or no? And here he had asked the first point, correct? When he is traveling at 5 kilometers per hour. So man speed is given. It is 5 kilometers per hour. So I'll equate these two sides. So I'll get 5 by sine 30. Sine 30 is half, is equal to Vr divided by sine 30. That is also half. Half and half will cancel out. Therefore, I get velocity of the raindrops to be equal to 5. Because velocity of the man is in kilometers per hour. This will also be in kilometers per hour. That matches with option number 3.